Okay, is my screen visual to you all?
Yes, sir.
Okay, thank you. So, okay, we'll start our session from here. And see, in cdse geography, we are getting nearby like 22 questions. So, we'll prepare fully in depth. And also, since we are going like slow, and geography is like ocean, so we'll study fast, and I'll say all those slides, everything what we are studying, and some topics also if we are covering in diagram and we are not studying, so about that one also I'll share. So when you are at home, just study about it, because now we have only 2 months, and also we have to cover all other syllabus also, like polity, history. So we have only less time, so I'll teach you all those important topics, and also everything will cover, so that you won't miss any questions. So sometimes if we might go fast, so if any issue in that, then you can ask directly. If anything, you can ask in the middle. Okay, so yesterday in time zones, we studied about why international deadline run in zigzag manner. So that we studied, that is due to the location of group of islands, that is Polynesia, Melanesia, and Micronesia. And yesterday we see in India our location time zone, that is at Mirzapur, 82.5 degree east. But in ancient time, not in ancient time, in British time, we had one more time zone, and that time zone, when they went away, when they went back to their own country, when we got independence, again we thought to make only one time. So after it, now these days, for this time zone, again that demand is going on in the eastern states. So see, we have one more that time zone, that is chai bagan time. That during British time it was there, but after they went back, our India country, our Republic India country decided to make only one time zone. So see, here we have our Mirzapur, Allahabad, that is time zone of our India. And this is one more time zone that is dividing this eastern states. See, till here we are getting like 5:30 hours ahead of GMT, but after here we are getting 6:30 hours ahead of GMT. So that's why, because of that people of eastern states, they are facing some issues to perform their activities. Means their productivity is becoming less. So that's why for that they are demanding one more time zone, that is chai bagan time zone. So 150 years ago, British colonialists introduced chai bagan time or bagan time, a schedule observed by tea planters, which was 1 hour ahead of IST, Indian Standard Time. So chai means tea and bagan means garden. So that tea garden area. So means it is covering all this eastern side. See, in Sikkim we have all those tea gardens. In West Bengal and Assam also we have. So that chai bagan time. So that is for tea planters. So this is one more time zone. It is not officially, but they are demanding for it. So I study about this one also. Okay. So now we'll start our session with motion of the earth. We have finished all this about the latitude, longitude, time zones, and all those. And which country have how much time zones, that we have not done, but that thing you can easily remember. So that thing I will share you in the group. That thing we had a study in the AFCAT group, AFCAT time. So that only some 6-7 countries are there. They have many number of time zones. So that I will share the slide. Just you go through it. And which country has the highest number of time zones? That is Russia. They have the 12 number of time zones. So just go through that so that you are clear through it. Okay, now we'll study about motion of the earth. So what are motions? Motions means like rotation and revolution. See, suppose if this is the earth, if it is rotating on its axis, then that is rotation. And if it is revolving around the sun, so that is revolution. So that spinning movement of the earth is called rotation. When it is spinning on its axis, that is rotation, and when it's revolving, that is revolution. So Earth's axis is the imaginary line that passes through the North Pole, that is Earth's center, and the South Pole. So Earth's axis is antipodal, that means it passes through the center of Earth, connecting two exactly opposite poles. So that Earth axis is antipodal. Why it is antipolar? Because it is passing through the center of the earth and connecting to poles. Everyone knows that earth rotates from west to east, and we studied that which are the two planets we are rotating east to west, that is Venus and Uranus. So remember that one. Okay, now everyone knows that yesterday we studied about that angle, how it is making the angle. So that same, see, our earth is in tilted manner, so we have our you might have our this equator as like a straight line from here, or sometimes here when it is revolving. So from that equator it is making 23.5 degree. That 23.5 degree, that is known as, this is known as orbital plane. This is orbital plane. So from, suppose if this is the equator, from here it is making 23.5 degree. So that from the orbital plane it is making 23.5 degree. And everyone knows that for a rotating, that rotation period, that is 24 hours, and due to rotation, day and night occurs due to rotation, and our earth is rotating on tilted axis. So that's why that it is making angle of 23.5 degree with the normal, that is, it makes an angle of 66.5 degree with the orbital plane of the earth. That means this is, suppose this is 90 degree, and this is, now this is equator. This is equator. Now you can take this as equator, and this one is line, circle of illumination. So from here, see, from here to here it is 23.5 degree. So now this is orbital plane. So in the elliptical orbit, from here to here it is making 66.5 degree. So this degree will be excluded. Now see, rotation period is 24 hours, and day and night, if questions comes that day and night happens due to which motion of the earth, that is rotation, and our earth is inclined. It is inclined at axis 23.5 degree. So see here for this orbital plane understanding, it is made, now this is 23.5 degree, and this is making 66.5 degree. So orbital plane, if the question comes for how much angle does it make, so that is 66.5 degree. Now suppose if we take this earth, so in this earth, now this line is known as circle of illumination. Suppose if now this equator is coming, sorry, this line is coming like this up tilting, that is coming at this side, then exactly that 23.5 degree, that angle making, that 90 degree and 66 degree, that angle making. So this one is known as circle of illumination, that 90 degree, that perpendicular is known as circle of illumination. And this one is, now suppose this one is equator, so we have here 23.5 degree south, that is Tropic of Capricorn, and 23.5 degree north, that is Tropic of Cancer. Okay, now shape of the earth. So many person used to just say our earth is a sphere, or our earth is elliptical, or our earth is in like a circle. So the shape of our earth is in geoid shape. So no other shape is the shape of the earth is in geoid shape. Why? And some sources they name it as like oblate square. Why it is geoid shape? See, actually it is fully like sphere, but at the both the pole side it is flattened. So we are calling it as geoid. So that is the earth slightly flattened at the poles. So it is flattened at the poles and it is bulged at the equator. So that's why we are calling it as geoid shape. The radius at the equator is larger than at the poles due to long-term effects of the Earth's rotation. So the radius, see, now we study, while studying in time zone, we studied that this latitude lines are not of same length. So here, see, at the equator side, latitude lines will be of more length. Then as we go towards the poles, it will be decreasing. So that radius is higher at the equator and it will decrease in the while going to the pole side. So that is also due to the speed of rotation, that is centrifugal force. So that centrifugal force is greater at the equator and it is goes and decreasing towards the poles. Okay. Now suppose if we take this equator, see our Earth's, one thing we missed, our Earth's diameter, this equatorial diameter if we take, like at the equator from if we take, that is 12,756 kilometers, and at the pole from the north pole to south pole, that diameter is 12,714 kilometer. So see, equatorial diameter is more. So at equator we have 12,756 meter, and from polar diameter it is 12,714. And now in this, see, at the earth we have gravitational field. But what is happening? See, earth or all those universe, everything is made up of one small that nebula matter, and after it evolved and it was like some explosion took place, then it broke into many parts. So that many parts, what happened, why they are revolving or rotating, and why they have made like a one planet or solar system, because they have their own gravitational field. So at earth also gravitational field is there, and since it is slowly cooling down, first it was in molten state, then it is slowly cooling down. So that cooling down is cooling all the materials. So that means that cooling down will be mostly all the materials will be settling down in the center. So when it will be cooling down. So due to that, at the center of the earth we have our magnetic field, and also we have our gravitational pull. So that magnetic field is making the gravitational pull, and due to that we have gravitational pull high at the center or near the equator, and as we go on, so outer parts like polar area, there we have the gravitational pull low. So as we go towards the equator, gravitational pull will be decreasing. The gravitational force is not the same at the different latitude on the surface. So that gravitational force is not the same. It is greater near the poles and less at the equator. This is because the poles are closer to the center due to the equatorial bulge. Thus, we have the stronger gravitational field. Wait a minute, guys. I think so there is some confusion. Wait, this one I'll clear it in a later stage. So this written part is correct only because I have got from some books. So no issue. So just gravitational field, we'll see it later. Temperature falls as we move from equator towards poles. So you know that at pole we have like days, that days will be like winter season type, fully ice will be coming down. So temperature as we go towards the poles, temperature is falling down, and at the equator, since that sun rays is falling directly on equator, so we have the temperature high here, and since that only some amount of sunlight is falling down towards the pole, so we have their temperature less temperature. So temperature falls at the surface of the earth as one moves away from the equator towards poles. So this is because of that geoid shape of the earth and the position of the sun relative to earth. The speed of earth is greater at the equator, so that rotation, that heavier materials are near the equator side at the center of the earth. So that rotation time, that it will be pulling all the materials towards it. So the speed of rotation of the earth is greater at the poles, thus the centrifugal is greater at the equator. So that speed of rotation is greater at poles, because of that centrifugal force is greater at the equator. So as centrifugal force and the gravitational force are counteracting forces, so they are acting in the opposite direction. So because of that only they are producing magnetic fields. Okay, now this was about the rotation. So due to rotation we have our day and night. Now revolution. So what is revolution? See, now this is sun, and the sun has a longer or higher gravitational field, higher than all the planets. So it is pulling, and all the planets they also have their own gravitational pull. So they are also trying to pull themselves away from the sun. So because of the gravitational pull of the sun, a gravitational pull of that planet, they are revolving around the sun. So that revolving around the sun, so that is known as revolution. At the same time, the earth spins its axis. It also orbits or revolves around the sun. So this movement is known as revolution. So the plane in which the earth revolves around the sun is called as orbital plane or the ecliptic. So around the sun, the place at which they revolve, that is known as orbital plane. So most large objects in orbit around the sun, that is near the planes of the earth's orbit, known as the ecliptic, and the planets are very close to the ecliptic, whereas comets are Comets and Kuiper belt objects are significantly greater angles to it. So you must know about the what is comets that we studied in the last class and what is Kuiper belt. So that everything you must know about it. Okay, see. Now due to revolution we have season change. So if day and night means that is due to rotation, and due to revolution we have our seasons change. So see, now this sun is at fixed at one place and our planets are revolving around the sun. So there only that planet's position are changing. So because of that, different parts of that particular planets they are receiving sunlight. So see, now sun is rotating in our Earth planet is rotating in anti-clockwise on the surrounding the sun. So at the different places we get in the different months time we get the sunlight. So because of that we have our season changes. So what is happening? See, suppose if we are revolving, now this is cycle of illumination, this is northern hemisphere, this is southern hemisphere. So this now if we take this as equator, this is tropic of Cancer, this is tropic of Capricorn. So this now suppose if sun is overhead this side, so at the equator we will be getting the highest amount. Then at the tropic of Cancer and tropic of Capricorn we will be getting a little amount. And we will study that why at the tropic of Capricorn we are getting less amount of sunlight even during the winter season, when that sun should be giving the highest light to the tropic of Capricorn. That also we will study. So seasonal changes, that is due to the revolution of the earth. Season change, that is revolution and also inclination of the earth. So if question comes, so season change is not only due to the revolution, it is also due to inclination of our earth. So our revolution period is 365 and 1/4 days. So that is our known as 1 year. So everyone knows that how we used to get 29 Feb, that and how we used to get leap year. So I think so everyone clear with that. 360 days is called a leap year. Then since we have our revolution period as 365 and 1/4 days, so because that 1/4, that after 4 years it is becoming 1, so we have 366 days. Now see here, now our sun is rotating, revolving around the sun. Our earth is revolving around the sun. So in December month our sun will be in the, when you see in December month, you would all would have studied about summer solstice and winter solstice. So summer solstice we have in June month. So that is 21st June. And in December month, on 22nd December, we have our winter solstice. So what is happening? This, see, sun after here December month, after getting that December month, after getting the winter solstice, again here in the in January month, slowly we are getting the sunlight this side. So that's why what is happening, that at this place, now this here we are seeing, here we are getting at half of the that earth, that is directly overhead of the sunlight. So at these both places we are getting equinox, that days and night both time are equal. And whereas in both in this winter solstice and summer solstice, we are not getting that days and night as equal. Summertime will have days will be longer, and in winter solstice days will be shorter. So since it is that full half of the part is located exactly overhead of the sun's light, so we are getting both the days and night equally. And winter, see, now this is our equator, and this is our tropic of Capricorn, this is our tropic of Cancer. So what is now, sun is our overhead of this mostly tropic of Capricorn area. But then also here we are not getting that much amount of light. Why it is happening? Because see, in the tropic of Capricorn area, if you come below the equator area, what even there is some presence of some dust particles. That dust particles, because that dust particles, and due to that refraction, you know that if it is going into some other medium, that time what will happen? If something is there, then that light will change its path. So due to that, what is happening? There are some particles here. So due to that, that sunlight, what is happening? Changing its paths and it is going towards the equator side. Equator side, Tropic of Cancer side. So that's why in winter time we have our days as shorter and we have our night as longer. But here, see, in this side, what is happening? It is actually overhead the Tropic of Cancer in June month. So here, what is happening? Here there is no refraction or something. So that overhead is coming. So because of that, we are getting our days as longer. But here we are getting our days as shorter. So winter solstice is on 22nd December and summer solstice is on 21st June. And here see, actually here it is 4th March. During this time we have our equinox. So that equinox we have it is on 4th March here. That is winter equinox, and here we have on 23rd September. So at these both places we have our 12-hour day and 12-hour night. So that equinox is what both days and night are equal. Okay, see here, all dates are mentioned here. So here is spring. See, now we used to say that spring season, autumn season. In spring season, what happens? In spring season, what happens? That during that time we have our there will be shading of trees. So during that time, why it is happening that shading? Because of that before that spring season we have our rainy season. So before that rainy season, that particular plants are getting water, and after some days we have our sun overhead of that area. So during that time they are getting enough sunlight. So that's why they are shedding their leaves. So see, winter solstice is on 22nd December, equinox 23rd September. Again here also we have equinox 21st March, and here 21st June. So here don't get confused. See here, in summer season, sorry, in the winter solstice, what is happening? In the southern hemisphere we are getting summer season, but that area winter we are getting in the northern hemisphere. So don't get confused. So that means winter we are getting in northern hemisphere. So here days will be shorter and night will be longer, and in the southern hemisphere days will be longer and night will be shorter. So this is all about summer solstice. So on 21st June, that northern hemisphere is tilted towards the sun, and the rays of the sun is falling directly towards the Tropic of Cancer. So because of that, area is receiving more amount of heat. So that we are getting the longest day and shortest night, and that is happening in northern hemisphere. So in the southern hemisphere, what will happen? It will be happening exactly opposite. So in southern hemisphere, we will be getting winter solstice. So similarly, that vice versa, it goes to winter solstice also. So winter solstice, that is for northern hemisphere. So in the southern hemisphere, we will be getting summer solstice. So that day in summer, that day will be longer and night will be shorter. So during summer solstice, the whole Arctic region falls within the zone of illumination all day long. So see, during summer solstice, what is happening? At the poles, we are getting 6 months days, 6 months night. So see, now during the summer solstice, that sun is overhead the Tropic of Cancer. So that now because of that, since it is that sun is over Tropic of Cancer, so this area, polar area also getting full amount of sunlight. So here we now doing when it is over the Tropic of Cancer, that is during the summer solstice, here we have the sunlight. And see, now our Earth is rotating. Our Earth is rotating at its axis, but these two places are its same place. Only it's rotating means this side and this side, that is changing. Not that their poles are changing, that north is becoming south and south is becoming north. So if you see on the globe also, if you rotate that globe, so only that side will be changing, not their poles. So during the Tropic of Cancer, that when it is overhead, so that time this northern pole will be receiving the sunlight. So since it will be, this place will be not changing, this during the summer solstice, this northern pole will be having 6 months sunlight. So 6 months days will be there, and while doing that time in the southern hemisphere it will be night. And similarly in winter season, what will happen? This in southern hemisphere you will be getting full days, and in the northern hemisphere we getting night. So in the pole side we have 6 months days and 6 months night. Okay, so during summer solstice, that is Arctic region, we have the zone of illumination, that is all day long. Okay, so see, southern winter, fewer days. So winter means fewer daylight hours, and so that will be less direct light equal to less heat. So that will be due to that that sun is not overhead of that area. So in winter we'll have the days shorter and night longer. Okay. Now about equinox. So on 21st March, and see our Earth is rotating anti-clockwise. So since it is rotating anti-clockwise, so we have our winter solstice in December month. So after that few days, since it is rotating, so after some days it will come to the like March month, then April month. So during that time, that sun will be that our Earth planet will be half of the our Earth planet will be fully to the sun's light. So during that time, what will happen? We will have our 12 hours days and 12 hours nights. So on 21st March and September 23rd, we have our equinoxes. And remember that when sun is nearer to the earth, that is 4th Jan. So on 4th Jan, see, in March we are getting equinoxes. So when sun is nearer to the earth, that is on 4th March, and when it is farthest, that is during the summer solstice time, that is on 4th July. So don't get confused. That is a static question. On 23rd September, it is autumn season, that is season after summer and before the beginning of winter, so in the northern hemisphere, and spring season in the southern hemisphere. And the opposite is the case on 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Okay. Days are always longer than nights at the equator. Why? See, why it is happening? Because now our that sunlight is falling directly to the equator side. So that you know that light is, since it is falling directly, so what is happening? There are no refraction in that area. That we studied that why in the winter time, actually in winter time, that days would be longer in the southern hemisphere. Days would be longer in the southern hemisphere in Tropic of Capricorn area. But what is happening? That days are not that much longer. Why? That is because of that dust particles. But at the equator, what is happening? That sun is falling directly. So that since sun is falling directly, there is no reflection. That light medium is not changing. So it is falling directly. So because of that, because of no refraction, we have our days longer and night shorter. See, so due to atmosphere, the sun is get reflected, that is bending of light due to changes exactly medium. When it is not the equinoxes, so during that time what is happening? That light medium is changing. So because of that, we have our, when it is not equinox, so because of that we are having the days longer and night shorter, or night longer or day shorter. So refraction is particularly stronger during the morning and the evening time, when the sun rays are slant. Even though the actual sun is below the horizon, its apparent image would appear above the horizon due to refraction. So this makes the days longer than nights at the equator. Now we will study about the perihelion and aphelion. So perihelion and aphelion, see what is happening. Our Earth is in elliptical type. So since it is elliptical type and it is revolving around the sun, so at some point that particular, since it is revolving in elliptical orbit, so that as some parts will be nearer to the sun. So that when our Earth is nearer to the sun, that is known as perihelion, and when it is farthest from the sun, that is known as aphelion. So aph means apart, so it is farthest. So aphelion means it is farthest. So that distance is 152 million kilometer, and when it is nearer, that time distance is 147 million kilometer. So when it is nearer, that is perihelion. When it is farthest, it is aphelion, that is 152 million kilometer. So the Earth revolves around the sun in elliptical orbit, with the sun at the one of the foci. So as that orbital path changing from being near circular to elliptical. So since it is rotating in an elliptical orbit, So that Earth's paths also changing from circular to elliptical due to gravitational influence of other planetary objects, particularly the moon. So the Earth is closest to the sun at its perihelion. So perihelion means it is closer, and aphelion means it is farthest. So that perihelion occurs during the 2 weeks after the December solstice. Perihelion exactly occurs 2 weeks after the December solstice. So perihelion during that time on 3rd January, sorry, I said 4th January, that is on 3rd January, we have our Earth nearest to the Sun. So don't get confused that during the summer solstice we are receiving the, we have the summer solstice and we have the longer days. So that means we are receiving a high amount of heat during summer solstice. So that time our sun is near to Earth. No. On 3rd January, exactly after the December solstice, after 2 weeks, we have on 3rd January, we have our perihelion. That means that is sun is near to the Earth. So perihelion, that sun is near to Earth, that is distance is 147 million kilometers. And on 4th July, we have our Earth farthest from the sun, that is aphelion. So that distance is 152 million kilometers. So about perihelion, and we have studied and see that perihelion is exactly 2 weeks after the December solstice, and that aphelion is exactly 2 weeks after the June solstice. That distance is 152.1 million kilometers, and perihelion distance is 147.1 million kilometers. Okay. How much does the elliptical orbit affect the weather on the Earth? So that see, since it is elliptical, so all the parts are not receiving the same amount of sunlight. So because of that, we have that our weather changes or season changes. So the difference in the amount of sun's energy that the Earth receives, that does not vary considerably between perihelion and aphelion. Throughout the year, the solar constant varies by little due to very small eccentricity of the Earth's orbit. So because of that, the winter is about 89 days and summer is about 92 long days. So in the northern hemisphere, we have summer slightly longer than the winter. And what are the duration of seasons? So see, our since it is rotating in elliptical orbit, and also our Earth is in geoid shape, so it is little you can see in elliptical type only. So the elliptical orbit that are affecting our weather by affecting the duration of season. So Earth is at farther from the sun in summer. So therefore the orbital velocity is at lowest. So it requires more time to travel from the summer solstice point to autumnal. So because of that only we are having our summer season longer. That is of 92 days. So vernal equinox we have on 21st March. That is one more spring equinox we have on 23rd September. So this all we have studied. Okay, now that was about perihelion. So say inside sun we have our elements hydrogen and helium. So that is helium means perihelion. That by that way you can remember. And peri means don't get confused. In Tamil you all know that peri means bigger, but not that one. So just leave that peri what. Just study about the aphelion. So up that A double P. That means you can take it apart. So apart means it is farther. So farthest. So that is aphelion means it is away. It means farthest distance. And perihelion just opposite. It is nearest. So don't get confused that word. Now perigee opposite. So this is both similar to that same sun type only. That both perigee and opposite. Only thing that G is different. That G is used for moon. So since sun have helium, so that you can easily remember that there we are using perihelium, and perigee means that we are using for our moons. So moon is also rotating around the Earth. So there moon is nearer to the Earth, that is known as perigee. When it is farthest, that is known as apogee. So don't get confused with that word. So in January 2019, perigee was 3,57,000 kilometers and apogee was 4,06,000 kilometers. So this don't you know to remember about this perigee and apogee distance, but remember what is known as perigee and what is apogee. So apogee means apart, so that is farthest. So apogee means farthest from the moon. So at that time Earth is farthest from the moon, and perigee means nearest. So that is perigee means moon nearer to the Earth. Okay. Now I have brought some questions to make you have clear understanding. So see, variation in the length of daytime and night time from season to season are due to. So due to what? The Earth's rotation on its axis, the Earth's revolution around the sun in elliptical manner, latitudinal position of the place, revolution of the Earth on a tilted axis. So anyone, which one is the correct answer? See, seasonal changes we are getting due to the revolution. So here they are saying that don't see that variation in the length of day and night. At night time we are having day and night changes. That is due to rotation. But day and night time, that time difference is taking place during that particular seasons. That is due to the revolution of the Earth on a tilted axis. So that season changes or weather changes we have due to revolution of the Earth and also its inclination of its axis, that is tilted axis. Okay. Now next question. This is about the which are the options correct. The shape of Earth is wide. Yes, we studied. This one is correct. The region that lies between Tropic of Cancer and Tropic of Capricorn is known as torrid zone. Yes, that is that equator, from equator to Tropic of Cancer and from equator to Tropic of Capricorn in southern hemisphere. So that is torrid zone. The temperature decreases from equator to poles because of the shape of the Earth. Yes, the temperature is decreasing because of that shape of the Earth. So this is also correct. The North Pole is a latitude. So can anyone tell me whether North Pole is a latitude or not? Anyone first say North Pole is a latitude, okay, but it is not a latitudinal line. We have at North Pole or South Pole we have 90 degree. So that 90 degree is a point, but that is not a line. So North Pole is a latitude, not a latitudinal line. So don't get confused. So all the options are here correct. Okay. Now we have finished about the motions of the Earth. So any doubt in the motions of the Earth, you can ask me now. Anyone, any doubt in the motions of the Earth? Okay, that means no doubt. Okay. So now we'll study about the interior of the Earth. That was about the motions of the Earth. All the latitude, longitude we have studied. Now we'll study about the interior of the Earth. So see, interior of the Earth. Everyone knows that we have our Earth divided into three parts. That is crust, mantle, and core. So inside the interior of the Earth, how we came to know that we have our different layers. So that is because of studying of the Earth's interior. So why that Earth is interior study is essential? Because for to understand about the Earth's surface. So what are the things are there inside that Earth's interior, and all those to predict the geophysical phenomena like volcano or earthquake. So why nowadays damage is less. If something is coming, okay, now human damage is less. Because of that, now since we study about the Earth, so we have set up that particular instrument to know about that thing. So because we are able to know about whether some earthquake is going to come or not before some time. So to understand the geophysical phenomena like volcanism and earthquake, to understand the Earth's magnetic field, to understand the internal structure of various solar system objects. See, all those planets, even the sun, they are made up from that one nebula that exploded. So they are made from that thing only. So mostly if that is our Earth is also made up of that only. So through that particular things we can also study about the sun. So through that particular thing you can also study about the other planets also. So that is to understand the internal structure of various solar system objects, to understand the evolution and present composition of the atmosphere. So everywhere we have our atmosphere. So to understand that composition of the atmosphere, and for mineral exploration. So for all these things we are studying the interior of the Earth. Now see, now our Earth. Now suppose if this is the center of the Earth. So this center of the Earth, now if you take this triangle and we have taken it out. So this one is center. So this one is inner core. Now this from here, this fully part is core. Sorry, this fully part is core. Then we have our mantle, and then we have our crust. So this one is inner core, then outer core, then we have lower mantle, upper mantle, then we have our crust. So see, now that particular triangle we are taking means we are dividing that our Earth interior layer. So that is core, mantle, crust. So this crust is in solid part, whereas mantle is in molten state. That is neither fully liquid nor fully solid. It is in viscous state. So mantle is in viscous or molten state. Then in core, see, core, one important phenomenon is that, see, that question have been asked in the serious exam. See, inner core is in solid state. Don't get confused that inside the earth now mantle is in molten state. That means core is also in the liquid state. Now this outer core we have in liquid state, but inner core is in solid state. So that we will study in later part why that is solid. Okay. Now crust length is 0 to 70 to 90 kilometers. So that is from here to 70 to 90 kilometers if you take, that is crust. Then from 90 kilometer to 2009 kilometers is mantle, and then from mantle to core that distance is 6378 kilometers. See, and our earth is, see, inside that crust, even in our crust also we have that upper crust, lower crust, the mantle, upper, lower mantle. So that they are divided by a particular discontinuity. So that discontinuity we have named it as here. See, outer crust and inner crust are they have the Mohorovic discontinuity. So that Mohorovic discontinuity is located between the outer crust and inner crust. Then between crust and then Repetit continuity is located between upper and lower mantle. And Gutenberg is between lower mantle and outer core. Sorry, Mohorovic is between lower crust and upper mantle, and Conrad we have in between the upper crust and lower crust. So this one you can remember by CMRGL. So just you can give some name so that will be you'll be able to remember all these names, that Conrad, Mohorovic, Repetit, Gutenberg, and Lehmann. CMRGL. So that is Conrad, M for Mohorovic, Repetit is for R for Repetit, then Gutenberg, then Lehmann. So Repetit is discontinuity between upper and lower mantle, and Gutenberg is between lower mantle and outer core, and Lehmann is between outer core and inner core. Okay. On the Earth's surface, we have different geological processes like volcano, earthquake, tsunami, all this. So in the Earth, we have different. On the surface of the Earth, we have different. Then suppose now we are having on the surface of that we are seeing. Inside the Earth also there will be some different phenomena. Because of that only we are getting volcanism. So because of that only we are getting that our Earth is shaking. We are getting earthquake in upper part. So that geological process inside the Earth, that processes that are caused by forces from within the Earth that are known as endogenous forces. So endo means in. So that within the Earth, inside the Earth body, that means inside down of the crust, that is mantle core, inside that part, that processes are taking place due to some forces that is known as endogenous, and if it is taking up of the surface, that is known as exogenous surfaces. So exo means out. So that up of this earth surface, if that is taking place, geological process is taking place due to some forces, that is exogenous forces. So the major geological features of the Earth's surface like mountains, plateaus, lakes are mostly a result of endogenous process like folding, that are driven by forces from inside Earth. So that folding, faulting, or mountain formation, that all that taking place, that is because of endogenous forces inside the Earth. Okay. Now to a study about our Earth, about the interior of the Earth, we have sources. So we have divided our sources into two types. One is direct sources, another is indirect sources. So in direct sources we have drilling, mining, volcanism. So volcanism is what? That upper during the volcano we are getting that lava in the upper part. So through that lava, that is coming from inside the earth only. So now from the lava we are taking some amount and we are studying about that one. So by studying on that one, now we are knowing that what all things are there inside earth, what materials, what minerals are there inside the earth. So volcanism is a direct source, and drilling and mining. So see, in drilling, what happened in Russia, in Koya Peninsula, that is Kola Peninsula, we try to study about the earth. So Russia is that drilling, they did not dig for the petroleum resources or anything. They drilling for the studying of the earth interior. So they were able to drill only till 12 kilometers. Earth's diameter is how much? 6,400 kilometers, but they were able to drill only 12 kilometers. Why? Because as we go deeper, the earth temperature will also increasing and also the pressure will be increasing. So that all those machineries were not able to work in those high pressure and high temperature. So we were able to drill till 12 kilometers in the Kola Peninsula in the Russia. And mining, the highest mining that we have in South Africa, that is for the gold mining. So that is 3.9 kilometers deep. And in that sources are seismic waves, meteors, gravity anomaly, magnetic field, temperature and pressure. So seismic waves means all those earthquake and everything. Why that is coming, and that due to that if some things are occurring. So because of that we are able to study about the interior of the earth. Then meteors that falling on the earth. See, meteors fall in the mesosphere, but some particles if left, they are falling on the earth. So by studying that also we are able to know about the interior of the earth, what will be the inside the earth, because mostly all the particles, all those planets and everything are made from the same part, that is a smaller nebula. So meteors also made from the nebula only. So because now if meteors are falling down, so by studying that also we are able to know about the interior of the. Then by magnetic field, we are able to know about it inside the earth. There is a magnet, there is a iron presence. So because of that only. Then temperature pressure. Now temperature pressure is why this drilling machine is not working, because of high temperature pressure only. So now we are able to know that inside the earth we have higher temperature and higher pressure. Then gravity anomaly. That gravity anomaly we will study here. See, direct sources, there is that deep mining that in Kola Peninsula. Then that gold mining in the Nong region, Nong region, that in Africa, South Africa. Then in that resources we have radioactive decay. See, the high temperature below the Earth. So due to that radioactivity, we have there is a frictional. So because of that, there is high amount of release of energy. So because of that, we have our high temperature. So that is radioactive decay. So by that we are able to study about the temperature. Okay. Now this meteorites is also one more part. Say that all those particles broken that we have between the Mars and Jupiter, that is asteroid belt. Then again after the asteroid belt, again it is becoming a small, and then it is coming into our space. So that is known as meteoroid. And then that same meteoroid, when it is coming in flame type, that they are burnt in the mesosphere, that is meteoroid. And meteoroid is falling on our earth. So don't get confused meteor and meteoroid. So meteorites and earth are born from the same nebular clouds, thus they are likely to have similar internal structure. So since meteorites are falling down the earth, so by studying that also we are able to know interior of the. Okay, now about this gravitation anomaly. The gravitational force differs according to the mass of the material. So inside the interior of the earth we have entire mass we have at interior of the earth only, inside the earth only, because they are that now because of that gravitational pull, or if suppose if some material is pulling down, then all those masses will go in the center, at the center places only. So because of that we have that highest mass at the center place only. So the uneven distribution of mass of materials within the earth influence this value. So that difference is known as gravity anomaly. So that gravitational difference at entire places of the earth, that is gravity anomalies. So gravity anomalies gives us information about the distribution of mass in the crust of the earth. That gravity anomaly, that is giving the information about the distribution of mass. Now by seismic waves also we are able to know about the earth's interior. So that is relating to the earthquakes. So seismic waves are waves energy that travel through the earth's layers and are a result of earthquakes. So in this waves we will be studying about that P waves, body waves, surface waves, then P waves, secondary waves, primary waves, secondary waves, that everything we study. So by C, now we know that the primary waves, they travel through solid, liquid and gas, and secondary waves, they travel only through the solid. So why we are not able to get the secondary waves on our Earth? So by that only we are able to study about the interior of the Earth. Secondary waves you are not able to get on the surface of the Earth. Why? Because the secondary waves travels only in the solid medium. They won't travel in the liquid state or gaseous state. So now since in mental side, if there is liquid or outer core we have liquid, because of that only that secondary waves are not traveling to the surface of the Earth. So by that seismic waves we are able to study about the interior of the Earth. Now this shadow zone we will study when we will study about the earthquake. Now seismic wave we have two types of wave, that is body wave and surface wave. So in body wave, that is inside the body, inside the earth, and surface wave is on the surface of the earth. So inside the body wave, we have two types of wave, that is primary wave and secondary waves. So primary wave, that is traveling in the all mediums, solid, liquid and gases, whereas secondary wave is traveling only in the solid state. So that's why because of that one, because of secondary wave, we are able to know about the Earth's interior, that there are some liquid present inside the Earth. Okay. Now about the crust. So crust, see, now that is our outer covering of our Earth. So that is material. Mostly in crust we have our solid material, and that crust is also divided into two parts, that is continental crust and oceanic crust. The crust is the outermost layer of the Earth, making up of 0.5 to 1% of the Earth's volume, or less than 1% of the Earth's mass. And in our Earth's surface, only we have our crystalline rocks or igneous and metamorphic rocks. So they are acidic in nature. Now see, this continental crust, and we have our oceanic crust. So continental crust, we have density as 2.7 gram per centimeter cube. Whereas this oceanic crust, this is made up of mantle area type. So this is here SIMA is present, silicon and magnesium. So here density is 3.0 gram per centimeter cube. See, this is continental crust and this is oceanic crust. So continental crust is expanded till 0 to 70 km or 90 km, whereas our oceanic crust only 0 to 5 km. See, now crust mantle core. See here. Now our average density of Earth, whole Earth, our average density is 5.5 gram per centimeter cube. So now we'll study about the crust. In crust we have our thickness from 70 km, 10 to 70 km, or I can say also 90 km. In some sources it might be 90 km. So thickness we have 70 km, but whereas in oceanic crust we have 0 to 5 km. And crust, this is Cr, silicon and ammonia is present, and oceanic crust is made up of mantle, so silicon and magnesium is present, and density is 2.7 gram per centimeter cube, and 3.0 gram per centimeter cube is the density of oceanic crust, and that is also the density of mantle. And see, continental crust is made up of granitic rock. So mostly all granitic rocks are present. So granite means what? This is acidic in nature. And basalt, oceanic crust is made up of basaltic rock, that is basic in nature. And this whole crust consists only 1% of the whole Earth. That our volume we have only 1% of the whole Earth. Like full Earth is crust, mantle and core. So in that we have only 1% volume, whereas mass is only 0.5%. So where all those masses and volume are lying, so that is mostly inside the core and mantle. So crust we have only 1% of the Earth, and mass we have 0.5%, volume 1%. Now this is about core. So core consists of volume that is 16% of the Earth, and mass is 32.5% of the Earth. See, this is very deep. We are going very deep. But okay, just go one time reading, because you might expect these questions. UPSC might ask some questions like this. So just give a reading through this one. Then crust, now you study about the crust. And mantle, we have from 100 to 2900 kilometers. So here what is happening? See, now we are staying in the crust only. We have our temperature like 35 degree, 40 degree line. But once we go deeper in the Earth, so our temperature will keep on increasing. So in upper mantle part we have 2000 degrees Celsius. Then again if you go in lower mantle we have 4000. Then as you go down our temperature will be increasing. So in the inner core we have our 6000 degrees Celsius temperature. That is equal to outer surface temperature of the sun. See inside core, sorry, okay, we do not study about mantle. Okay, mantle we do not study. See mantle consists of silicon and magnesium, and here volume consists of 84% and mass is 67%. So don't get confused, because since core is having the highest depth, but don't get confused. As we go deeper inside that, see this side, this one is decreasing. So now only length, that depth is increasing, but they don't have that much volume and mass. So that volume and mass that mostly consists in the mantle part. So volume we have 84% and mass 67% in the mantle part. And as you go inside deeper in the earth, at every 32 meter, 1 degree temperature increases. 1 degree Celsius temperature increases. And density, see density, if we have 3 to 5.7 gram per centimeter cube. So in mantle we have 3 gram per centimeter. So 3 to 5 gram, 5.7 gram per centimeter we have our density. In upper mantle it is 3.0 to 3.3 gram, and in the lower mantle it is 3.3 to 5.7 gram per centimeter cube. And inside the mantle, if they ask about the components of the elements, so inside mantle we have oxygen, silica and magnesium. So oxygen is 45% and silica 24% and magnesium is 23%. So remember about these components, composition of the elements, oxygen, silica and magnesium we have inside the earth. See, mantle we are studying, so SEMA we know that silicon and magnesium is there. Oxygen also is there, that is 45%. Then about the core. So core part is known as Nephe. That is, Nephe means what? Nickel and ferrous. So inside the earth core we have presence of iron material. So that's why we have named it as Nephe. So it consists of totally 16% volume of the earth and mass is 32.5%. See, it is consisting only 16%, but mass here is high. Why it is high? See, here it is consisting 84%, but mass is only 67%. And why it is high here? Because what is there inside in the inner core we have our solid part. Outer core is liquid, but inside the inner core we have solid part. Why that is solid part? See, as we going down the earth, as you going deep, then our temperature and pressure both are increasing. So temperature increase, okay, that way materials will be changing into liquid, and then again it will change into gaseous part. But since that temperature is increasing and also the pressure is increasing, so because of that pressure increasing, so that all parts are making that particular part to be a subsidized one. So because of that, particular part have become solid, and since it has become solid, all those particles are they don't have any gaps, so their mass they consist of lot of masses. So inside the inner core we have volume only 16%, but we have mass as 32.5%, and core density of core side is 9.5 to 15 gram per centimeter cube. Outer core we have 9.5 to 12.6, and in inner core we have 12.6 to 15 gram per centimeter cube. And see, we study that outer core is liquid state and inner core is in solid state. And in mantle, see, we say this both upper mantle and this both mantle, they are in molten state. They are highly viscous. They are neither fully liquid nor fully solid, and they are also easily breakable. This mantle part, they are mechanically breakable easily. That's why we have volcanoes and all those systems. Okay. Now this was about the now see why we have magnetic field inside that one, inside our earth, and why we have electricity. See, now this what is happening inside the earth core, we have our presence of nickel and iron. So what is happening now that all those iron parts are settling down, they have become solid. And we have, from the upper part, from the crust, there is large amount of pressure put on this inner core. So because of that huge amount of that iron, presence of iron, and our earth is rotating on its axis and also revolving around the sun. So because of that rotation of that iron skins, it is rotating, so that core also will be rotating, so that inner part, that iron is rotating. So because of that, they are producing fields, so they are producing like solenoid. So because of that, it is becoming induced magnet. So that's why we have our gravitational pull and that bar magnet. So because of that, our rotation, revolution, and pressure, that iron is becoming as induced magnet. That magnetic fields are produced in a circular way, that is solenoid way. So because of that, we have magnetic field. So now about lithosphere, asthenosphere, and barysphere. See, now this upper part is crushed, and lithosphere, we are staying on the lithosphere. You can say also as rocky sphere, because lithosphere means it is soil. So we have our rocks also. So full crust is lithosphere, but full crust plus some parts of upper mantle, that is solid. Okay, so some parts of upper mantle that is solid and crust, that consists lithosphere. Then from down of the upper mantle, little down like 5 kilometer if you go, then that part mantle is known as asthenosphere. Then full we have mantle part, that is mesosphere. Then full core part is known as barysphere. So about lithosphere and asthenosphere question have come. So asthenosphere is in which interior of the earth? So that is in the mantle, and lithosphere is in which interior layer of the earth? So that consists of both upper mantle and crust. So full crust and upper mantle. And where asthenosphere is only in upper mantle, only little parts. So that is fully in mantle part. So don't get confused that one. So this is all about lithosphere, asthenosphere, mesosphere, barysphere. And about this discontinuity, you all can remember by CM, RGL, Conard, Morovic, Deputy, Gutenberg, Lehmann. So Conard is for upper crust and lower crust. See, all those, we have 6 layers. All those, we have 3 layers, and all those 3 layers are divided into half of parts. So that they are separating, that is known as discontinuity. So that crust is divided, that upper crust is divided by Conrad discontinuity. Then we have lower crust plus upper mantle, that is by Mohorovic. Then upper mantle and lower mantle, that is by Repeating. Then lower mantle and outer core, that is by Gutenberg, and outer core and inner core, that is by Lehmann discontinuity. Now we'll study about the elements on the Earth's crust. So this question have come in many exams. So remember about that particular composition of the elements. So this we are talking about the Earth's crust. So most abundant elements of the Earth's crust is oxygen. So oxygen we have 46.6%. Then we have silicon, aluminum, then iron. So remember about this order of these 4: oxygen, silicon, aluminum, and iron. So this question has come, that which one of the element which is most abundant on the Earth's crust? So that is oxygen. So okay, this was all about the interior of the Earth. So any doubt in the interior of the Earth, you all can ask for me now. Any doubt, anyone? Any doubt? Okay, see, we have finished all this interior part of the Earth. Tomorrow we'll study about rocks. So tomorrow we'll study about rocks. Then also we'll study about earthquakes, that all those T waves, S waves, shadow zone. So everything tomorrow we'll finish it about rock. And also if we have time, then we'll study about plate tectonic theory. After studying from that plate tectonic theory, then we need maps, so that we'll be studying about all those landforms and particular locations. So today we'll finish up with this one only, and tomorrow we'll study about rocks, earthquakes, and plate tectonic theory. So okay, that's all for today. And if any doubt, any part previously we have studied and including today. So any doubt you can ask from me now in this session. Any doubt in anything? Anyone, any doubt? Okay. So that's all for today. Now we have finished our full things. Tomorrow we'll study about rocks, and then we'll see about the earthquake. Then we'll see about the plate tectonic theory. So okay, that's all for today. Now just go through the all slides and study. Just do a revision. That like one day, okay, just go through all slides, do a revision, and if you have PIQs, try to solve PIQs so that all your concepts are clear. However, I'll bring all those PIQs in later stage. Like if suppose if you are not able to study in our classes, so that I'll put it on a YouTube channel so that you can watch by yourself also. That fully in English I'll put it so that you can watch by yourself also. All those PIQs. If we don't have time to solve it here. So that's all for today. We'll meet again tomorrow at the same time. And if any doubt in anything or anything, any related concept, you can ask me through the personal message. Okay. Now you can leave now. Thank you. Bye bye. Again, we'll meet tomorrow at the same time.